Okay, we are continuing with the foundations for inclusive growth as part of strategies for climate adaptation. In this section, we are still looking at sample targets and indicators, and we'll soon see how simple indicator-based analysis can help prioritize action. Here, taking action, poverty headcount or change in poverty headcount last 5 years can be a simple target and an indicator. Growth in income of bottom 40%. Average income of farmers. These are kind of things that go into census, which in India, for example, is done every 10 years. Various countries have different frequencies, but pretty much every country does a census of some sort to track the demographics and the various statistics like this. Percentage of farmers with access to fertilizers or improved seeds, average share of household budget spent on food and beverages, access to modern energy, improved water or sanitation, number of power or water outages per year, share of population with a bank account, health care coverage or covered by social protection of some sort, social welfare, total social protection spending as a part of the government revenues, and number of conflict related deaths in the last year. These help often also compute vulnerabilities and exposure to various natural and anthropogenic hazards. Here again, looking at COVID-19, strong healthcare systems are vital, so that follows well on the indicators we were talking about. The current crisis linked to COVID-19 illustrates the need for strong healthcare systems that can quickly detect emerging diseases and promptly react in the case of an epidemic. In India, everybody got vaccines, but then there were long lines for getting free vaccines, but those who could pay could get vaccines with a much shorter line, etc. So various ways in which you can deal with such healthcare system issues in the face of a rapidly evolving disease. There are clear synergies with building the population's resilience to health-related climate change impacts. We can expect significant investments in healthcare systems in the next few years to improve the world's ability to manage epidemics and new diseases, and there is an opportunity to ensure that these new systems are designed to swiftly identify emerging diseases due to climate change and provide a prompt, appropriate response. Whether this will happen as a globally coordinated effort or at least regions with different countries with porous borders will do this is not entirely clear, especially if there is no pandemic for another decade. Then COVID lessons may be quickly forgotten at some level, and the entire idea of cooperating and collecting data for making these decisions may not actually work out. In the context of One Health, the need to respond quickly to emerging diseases also applies to diseases affecting animals and livestock. There is always the threat of zoonotic and diseases that are spreading and vector-borne diseases, etc. So all these things are lessons that are probably relearned during COVID, and it'll be very good if we can keep those lessons in a codified form, not only at national levels but at international levels as well. Let's look at a toolbox here. A simple indicator-based analysis to identify priorities for action. If the socioeconomic context and development trends do not help reduce people's vulnerability to climate change, it's unlikely that targeted intervention can make a big difference. So you need really an indicator-based analysis that will lead to reducing people's vulnerability to climate change. A simple analysis based on available indicators can help identify which socioeconomic trends are problematic from a climate change vulnerability perspective and therefore identify promising opportunities for change. We will look at this in Annex 2, but in India, for example, the computation of socioeconomic vulnerability to hydroclimatic hazards showed in one study that educating women, even beyond grade 3 or 4, helps reduce their vulnerability to natural hazards, because presumably the women are better at assimilating early warning system information or weather forecasts and take action to protect family and property. So these things really help then to take actions to reduce vulnerability. Annex 2 provides some examples of how widely available indicators such as the World Development Indicator can provide insights on possible policy priorities to ensure that development contributes as much as possible to adaptation and resilience. We'll look at figure A1, which shows that Mongolia lags other countries at similar income level in terms of access to improved sources of water, suggesting the existence of opportunities to build the population's resilience in this sector. Right, so here is the figure, indicators of access to improved water sources. This is from the World Bank Indicators World Development Indicators report. GDP per capita 2017, purchasing power parity in 2011 international dollar values going from 0 to 20,000, and this is population with access to improved sources of water in percentages. And as you can imagine, higher the income level, higher the population with access to improved sources of water, which means people who are poor simply don't have access to pure water, which obviously leads to all kinds of diseases and loss of productivity, loss of children, infant mortality, infertility, all kinds of problems, right? Fay et al. 2020 provide an indicator-based analysis to look at the correlation between exposure and vulnerability to disasters and climate change, and macrofinancial risk indicators generated by the Economist Intelligence Unit. This analysis highlights that most countries that are heavily affected by disasters or expect to be strongly affected by climate change already face significant macro-fiscal risks. Okay. Figure A2 we will look at, which illustrates this correlation with disaster losses and public debt risks. Okay, sorry, I misplaced figure 2 too far. We'll go back. So here is the EIU debt risk index. 100 is high. This is for 2017, and here is the average losses from natural disasters. Average losses from natural disasters and EIU debt risk index for 2017, and you can see the various countries. There are those which have very low EIU debt risk index, and their average losses from natural disasters as a percentage of GDP is also correspondingly very low. But as you go into regions with very high EIU debt risk, there is a combination of the natural disasters they face and the debt risk. So some countries end up here. Okay, you can see Oman, Thailand, and so on. So obviously there is a strong relation between oops, I have to go back. Economist Intelligence Unit debt risk and disaster risk losses. Okay, losses due to disasters. It's also possible to use some of the indicators recently developed to measure socioeconomic vulnerability or resilience. These have different scopes, focuses, strengths, and weaknesses, but most allow users to first explore aggregated indicators such as resilience or vulnerability, and then explore disaggregated indicators such as farmer productivity or exposure to storms to identify opportunities for improvement in a given country. Examples of such indicators include INFORM, Joint Research Center of European Commission puts this out. INFORM measures the risk of humanitarian crisis and disasters and how the conditions that lead to them affect sustainable development. It calculates risks as the combination of three equally weighted components: hazard, exposure, and vulnerability, and the lack of lack of coping capacity. This is similar to what was used in IPCC AR5, exposure, hazard, and vulnerability, and AR6 added response, which corresponds to lack of coping capacity and how the system responds. And the GAIN Index, the Notre Dame Adaptation Initiative that we mentioned before in the summary, and in the GAIN score measures a country's preparedness for climate change, including but going beyond natural hazards and depending on its readiness and vulnerability. I have left the window open, and there's a very strong hissing sound from the winds, which unfortunately I can't avoid because I need the breeze to survive this massive heat and humidity in Mumbai. This is May 29th here, so hopefully the monsoon will arrive soon and cool things a little bit. It measures a country's vulnerability by assessing its exposure, sensitivity, and capacity to adapt to the negative effects of climate change, looking at 6 sectors: food, water, health, ecosystem, services, human habitat, and infrastructure. It measures a country's readiness by assessing its ability to leverage investments and convert them into adaptation actions, looking at economic governance and social readiness. So those are 2 indices. The third one, World Risk Index, UN University and University of Bonn. This index measures the vulnerability of 171 countries to natural disasters. It's composed of 4 main indicators. The indicators always matter, and it doesn't have to be universal. That local vulnerability and coping capacity may depend on local indicators, and also may depend on sectors, whether you're looking at agricultural vulnerability of health, people, socioeconomics, etc. It's composed of 4 main indicators: exposure to natural hazards, susceptibility, which depends on socioeconomic conditions, coping capacity, which depends on preparedness, governance, and security, and adaptive capacity related to future natural events. So this report, this book that I'm using, you can call it a book or a report, doesn't do sectoral based adaptation strategies. It is giving you national level overall climate change adaptation, so the indicators also tend to be not sectoral. Global Climate Risk Index from German Watch, published annually. This index analyzes the extent to which countries have been affected by weather-related losses, including storms, floods, and heat waves. The index is populated with data from Munich Re's, a reinsurance company, NatCat Service, and the International Monetary Fund, among others. Okay, so we looked at figure 2 already in terms of average losses from natural disasters and the EIU debt risk index. Figure A3 shows the socioeconomic resilience as a percentage by GDP per capita for 149 countries. So you are looking here at GDP per capita in terms of purchasing parity, power parity, whatever this. It basically takes currencies and tries to make adjustment for differences and see what your purchasing power is. So purchasing power parity, that's what it stands for. Socioeconomic resilience in percentage. So you can see that when GDP per capita is low, you have a large range of socioeconomic resilience, and as the income increases, there are some exceptional cases here which include very rich countries like the US, for example. The socioeconomic resilience also changes. So here the resilience has to be carefully considered, because poor people may not have much to lose, and they may be able to pick up and move and recover quickly from a loss. But if you have wealth and your per capita income is higher, you may be more susceptible or less resilient in terms of recovering from losses. So if you are a homeowner and you lost the house, you may be less resilient than a person who is living in a hut or some other temporary shelter and can rebuild quickly. So those kinds of details matter here. Okay. Continuing with Toolbox A, taking action, the World Bank developed the Socioeconomic Resilience Indicator, now available in 149 countries that we looked at in the previous slide. Socioeconomic resilience is defined as a country's or population's ability to cope with and recover from direct damages caused by natural disasters. It's estimated with a simple model of how households can manage disasters and estimates of direct disaster impacts. For each country, it provides an estimate of socioeconomic resilience and risk to well-being, which has a definition itself. Socioeconomic resilience depends on three main dimensions: the difference in exposure and vulnerability between richer and poorer people. If poor people are more exposed or vulnerable, the same economic loss in absolute terms will have a biggest impact on their well-being. Access to tools and instruments to manage the shocks such as remittances, savings, emergency borrowing, insurance, and social protection. The government's capacity to respond and support the population. Because the indicator is based on a model, it can also be used to estimate the benefits of various interventions. So you can perturb the various parts of the components of the model to see how the interventions can improve resilience or reduce vulnerability. For example, A4, which we will see next, shows the benefits of 11 different policy interventions in terms of reduction in asset and well-being losses in Malawi, a country that's quite poor. The same reduction in asset losses of say 1,000 reduces say $1,000 reduces well-being losses more if the beneficiary is a poor household for whom $1,000 is a lot. Similar estimates are available for all countries on the World Bank platform. Alagat, who's the lead author here, has done a lot of work on this. So let's look at figure 4, effects of policy options on asset and well-being losses in Malawi. So here you are looking at losses in millions of dollars per year going from 0 to 30, and there is also a negative scale to show benefits. So avoided well-being losses and avoided asset losses are being looked at. Increase social transfers to poor people to at least 33%. So that's going to obviously affect the asset and well-being losses greatly. And reduce exposure of the poor by 5% of total exposure. So you have avoided asset losses as well as avoided well-being losses in to the order of 25 million per year. Accelerate reconstruction by 33%, universal access to early warnings, post-disaster support package, reduce asset vulnerability by 30% of poor people, 5% of population. So these are models, so you can perturb it in any way you want. So this is just to show sensitivity of the various interventions. Develop market insurance for non-poor people, reduce exposure of the non-poor by 5% of the total exposure. You can see their asset losses also tend to be about as high as avoided well-being losses. Universal access to finance, increase income of the poor by 10%. So you have here gains, not just avoided losses. Reduce asset vulnerability by 30% of non-poor people, 5% of the population. Similar amounts of avoided well-being losses and avoided asset losses. Okay, so this is the section on foundations of adaptation for inclusive development and economic growth, and we'll come back and look at the next section in the next podcast. Okay.